Welcome everyone. I am Sayed Mohsin Reza, a Ph.D. student from University of Texas. Today I am presenting my paper titled on performance analysis of machine learning approaches in software complexity prediction. My paper ID is 410. Software complexity is an undesired characteristic of a software. In a software, if software complexity is increasing, it reduces software maintainability and sustainability. We can categorize the complexity in two levels, class level and method level. In both categories, the complexity can be affected by many factors. And those factors can be break it down to code structures, object-oriented properties, and source code metrics. Currently, there are some code rules you need to apply on IDE to detect class complexity. In our paper, we are trying to use machine learning techniques to automate the process and get rid of those manual processes. So in summary, our research objective is to use machine learning techniques to build complexity classifiers. And machine learning can get rid of those manual processes or applying code rules to detect class complexity. We have another objective is to compare the performance of different machine learning classifiers. We also report the best technique based on the performance of those machine learning classifiers. The motivation comes from the fact that early detection of a software complexity will empower better software maintenance. And if we can effectively maintain the software, it will facilitate better quality of that software over time. And well-qualified software always facilitate four things: enhance future software maintainability, enhance sustainable software over time, minimize software development efforts over time, and finally, and the most important, reduce the software development cost. So from that motivation, we came up with two research questions that we'll answer in our research paper. The first research question is how source code metrics are correlated with quality attribute named class complexity. This question will reveal the relationship between complexity and source code metrics. Research question 2 is how accurately can machine learning approaches predict class complexity from source code metrics? This question is targeted to find out the accuracy of the machine learning approaches. And after that, we'll select the best techniques that we have from our research. So as you can see from the figure, there is a study design. For that study design, we have started with dataset collection, then dataset preparation, and we have done some Pearson correlation to find out the feature set for our machine learning. Then we have done some training and testing. And after training and testing, we evaluate the performance of machine learning classifiers and then report the best techniques. As a first step, dataset collection, we need for our machine learning classifiers a diverse set of repositories. To do that, we search code-based repositories using a model mine tool. This tool is capable of searching repositories with different search criteria. You can note it, this tool is published before as a research paper also. So we use a published works in our research. To search the code-based repositories, we follow some criteria. A repository with primary language will be Java. We are not testing other languages. A minimum 5,000 commits, which is a proxy of maintenance. High number of commit means maintenance is good of that software. 100 active contributors, and also 3,000 stars and 500 forks should under that repositories. It means the popularity of that repositories. And we have get a list of repositories under this search criteria. But we have selected 10 repositories, which you can see on the right side graph. And also you can see we selected those diverse set of repositories to ensure we are the technique we have applied in our machine learning is well trained. In total, we use 38,778 classes selected. After the selection of repositories, we extract 18 source code metrics for each class. And you can see a list of source code metrics on the right side. Some of them are lines of code, weighted method count of that class, depth of inheritance tree of that class in the project. So there are 18 source code metrics we have selected. Also, we have extract current complexity using a CodeMR tool. This is also a published tool in a Springer journal. So then we combine these two data set by class name to ensure a better complexity classifier data set for the model. In our dataset preparation, we have removed the duplicate observation. CodeMR tool creates some duplication. That's why we remove those. Then we find out the outliers and make sure that we are removing the data bias data points. And we also visualize some explanatory data analysis on input and target variables. One of the graph you can see on the right side. So complexity, high and low complexity are visualized in terms of lines of code and weighted method count. You can see we can separate them very well. However, if we have multiple variables, what we need to use, we will use machine learning to classify those. So we create a training 80% dataset and testing dataset. To answer the first correlation results, the Pearson correlation, we apply Pearson correlation on our dataset and it reveals depth inheritance tree. Some source code metrics have high impact. On the right side, you can see DIT, depth inheritance tree, RFC, response for code, CMLOG, class method lines of code has high impact on source code complexity. So these are the features that we can select for a machine learning classifier. In training and testing, we use 5 different machine learning to classify the complexity. The first one is naive bias, then logistic regression, decision tree, random forest, and AdaBoost. These are well-known classifiers and used in similar research. And we have performed 10-fold cross-validation to ensure the reduction in variability of performance results. So now I will talk about the result of performance of our models, and that will answer our research question 2. We have seen from the right graph that decision tree and random forest classifier has the highest accuracy in accuracy and precision compared to other classifiers. We have also seen random forest has the highest recall and F1 score. Is that all to declare the best technique to predict software complexity? I think no. We have used another metric, it called false negative rate, to reduce the risk of false alarms. So false negative rate always gives us false alarms in terms of complexity. So in our research, you can see higher FN rate indicates that high number of high complex classes are detected as low, which is very risky model. So we need lower FN rate. So we can see from the right graph, random forest shows the lower FN rate. So you can tell random forest is the best technique to detect software complexity. In conclusion, we can say we need to maintain the software quality, and one of the way is to take proper action before classes have become more complex. So in our research, we compare 5 different machine learning approach, and random forest is one of the best model that predicts in software complexity. And it can be used industrial uses also. And in long-term outcome, we can ensure sustainable software and minimize software development cost, and finally reduce the software development cost over time. If you have any question about my research, email me at the following email. Thank you everyone for watching my presentation.